All right, so like I was telling you, we're going to look at the graphs of the four functions. We spent a lot of time looking at sine and cosine waves, and with all the phase shift and the horizontal shift and the stretches and the shrinks and all the A, B, C, and D values. We're now going to look at the other four graphs and kind of add some of those in. Okay, so we'll get into that. Good news is, well, good or bad news. So today's lesson is a little bit long. It'll take the whole time to get through it. But tomorrow, then, I don't have anything new for you. Tomorrow will be a question and kind of work day, so you can have some time in class to make sure that you're understanding what we do today. So let's get into it. Okay? If we start off looking at the graph of tangent, here's where it comes from. Reminder on a few things before break. Remember, tangent is defined as sine of x over cosine x. Okay? Sine over cosine, which means if you think back to rational functions when we were graphing, you cannot have 0 in the denominator. You can't divide by 0. And therefore, anywhere the denominator would equal 0 is undefined. And that means you've got vertical asymptotes at those places. Okay? So wherever you would have, so in this case, wherever the cosine equals 0, we have a vertical asymptote. Okay? So if we go to the unit circle, that's why I had you take that out. Going back to sine and cosine, which one is cosine? The x coordinates or the y coordinates? X coordinates, good. Where does the cosine equal 0? Where's the first spot? Was it? Right? Yep, 90 degrees or pi over 2. Okay, cosine of x, cosine is 0. Where's the next time cosine equals 0? 3 pi over 2 is the next one. Okay, and then we could keep going from there. We could go another time around, we could just keep going. We could go the other direction as well. And I'm going to kind of work from 0, I'm going to work both ways to start off. So in the positive direction, it's pi over 2 and 3 pi over 2. And then we could go the same thing in the negative direction. Negative pi over 2, and then negative 3 pi over 2. And keep working that way. So if we add that to the graph, we'll take a look at the period when we're done. We'll come back and take a look at that. So if we add that to the graph, come on, there we go. We said at pi over 2 is going to be our first vertical asymptote because that's where the cosine would equal 0. So let's put that in. And we said at 3 pi over 2. We also said if we went in the negative direction, we would have a vertical asymptote at negative pi over 2 and negative 3 pi over 2. Well, maybe. Change colors here. I'm going to try. There we go. So we said at those values, we have vertical asymptotes at all of those different values because that's where the cosine of x would equal 0. So when graphing tangent or cotangent, that's the first thing you need to do. You need to make sure you figure out where are your vertical asymptotes. Second part then we're going to take a look at is, before we talked about like midline points, now we're really just going to be looking at like x-intercepts. Okay, where are the x-intercepts? And the easiest way to talk about it is the x-intercepts are always halfway between your asymptotes. Okay, they're right in between. So if you take a look, for example, negative pi over 2, positive pi over 2, halfway between. In this case, happens to be 0. Okay? There's one of your x-intercepts. What's halfway between pi over 2 and 3 pi over 2? Halfway between pi. Yeah, in this case, halfway between 1/2 pi and 1.5 pi is pi. Okay? So if we put another one in there, right here at pi, we have another x-intercept. And then again, we could keep going. I'm going to go in the negative direction as well. Halfway between negative pi and negative 3 pi over 2 would be negative pi. And once you've got your asymptotes and once you have your x-intercepts, we could add a bunch more points, but in general at this point we're just going to sketch the rest. And if you take a look at the poster over on the wall, it looks kind of like that, where it starts down as you work from left to right, kind of starts down low and ends up, if you plotted a whole bunch more points, oh geez, sorry, has that general shape to it. present. We made it 7 minutes. So as you take a look, there's your graph right there, okay? Find the asymptotes, figure out where the x-intercepts are halfway between, and then you can sketch the rest from that point. Okay? And granted, we'll go through an example, and we can add in stretches and shrinks where the asymptotes move and that kind of stuff. But in general, here's what the parent function graph looks like. Okay? Good news is there's only two differences with cotangent. The asymptotes are going to move to a different spot. We'll talk about why. And then the shape of the graph is just a little bit different, but not much. Okay. So let's actually go to the next part. Let's go to cotangent. So same exact idea, except now, because cotangent's the reciprocal, I no longer have to worry about where the cosine equals 0. Now I have to worry about where the sine is equal to 0. Okay? Because I can't have 0 in the denominator. So wherever the sine would equal 0, it's undefined, meaning there's a vertical asymptote at that spot. Okay? So again, if we go back to our unit circle for a second, where does the sine equal 0? Where's the first spot? 0. Right here at 0. Where's the second spot if I'm going in the positive direction? Pi is the next time sine equals 0. Where would the next one be? I think you said it right. 2 pi would be the next one. And then 3 pi, 4 pi. Okay, so you're working your way around, or again in the opposite direction. You'd have 0, negative pi, negative 2 pi. You could go either direction. So if we take that information, oh, and I'll have to go back. I forgot about the period on the last one. We'll come back in a second. So if I take that information and we add it to this graph, we said we have vertical asymptotes at 0, pi, 2 pi, 3 pi, and so on and so forth. So let's add those in. Here's 0. Oops, that's not what I wanted. So here's a vertical asymptote at 0. Let's go over here to pi. If I wanted to add another one, we could put 3 pi, 4 pi. We could keep going as long as we want. And same thing, I'm going to go in the negative direction as well. So at negative pi and negative 2 pi, we also have vertical asymptotes. Now, same exact idea. Once you found the asymptotes, now we go to where are the x-intercepts. Okay? So if we take a look at the x-intercepts, once again, they're going to be halfway between the asymptotes. So what's halfway between 0 and pi? Pi over 2. Okay? 1/2 pi. So at this point right here, we would have an x-intercept at pi over 2. What's halfway between pi and 2 pi? 3 pi over 2. Okay? Remember, halfway between, all you're really doing is just taking the average. Add them up, divide by 2. Okay? So if you add those, you get 3 pi. Divided by 2 is 3 pi over 2. And same thing again in the negative direction. I would have a negative pi over 2 and negative 3 pi over 2. So if you notice, basically the same thing as tangent. Find the asymptotes. They're in a different spot. They're not at the pi over 2's. Okay? They're at pi and 2 pi, and they've been shifted a little bit. And the second part, here's the second difference to the graph. Because cotangent is the reciprocal, as you work from left to right, instead of increasing, the reciprocal actually flips it, and it is decreasing instead. So it looks something like that. Find the asymptotes, find the x-intercepts, and then from there you can sketch everything in. Okay? Quick question. I didn't ask it before because I forgot. As you work your way through, we said for sine and cosine waves, it takes 2 pi to completely go through the wave and then the pattern to repeat. How often does the pattern repeat here? What is it? Somebody said it. Pi. If you take a look, from 0 to pi, you've got one of those full waves. Then another full wave from pi to 2 pi. Every pi, this pattern is repeating. So that is your period, not only with cotangent, but if we go back for a second to the tangent and you take a look, it's the same thing with tangent as well. From pi over 2 to 3 pi over 2, that's a distance of pi. Negative pi over 2 to positive pi over 2, that is a distance of pi. Okay, so the period for both tangent and cotangent is pi now instead of 2 pi. How we doing? Okay on that so far? All right, let's keep going. Let's kind of summarize something and then we'll go through an example. So if you take a look, if we summarize equations here a little bit, y equals a times either the tangent or cotangent, almost the same thing as what we had before with sine and cosine. Notice one thing, there's no plus d at the end. Not that there couldn't be, we're just not going to worry about it, because realistically, you're still going to have an x-intercept, you're still going to have vertical asymptotes, so that's what we're going to focus on. We're not going to worry too much about the vertical shift at all. Notice as well, amplitude. There is an effect. It's not that there isn't an amplitude. The value of a is still your amplitude, but it's not going to be noticed very much on the graph. It's just that idea of whether you stretch it or shrink it, and so it's how steep the curve is. But it's because we're sketching it, it's not super noticeable, so it's not something we're really going to worry too much about either. So our main focus is going to be on B and C with the period and where are the asymptotes and are they stretched or shrunk or whatever. That's what we're going to take a look at. That's going to be our main focus when graphing tangent and cotangent. And so if you take a look, a couple of things, I'm going to have you add something to your sheet that I forgot to add before I made copies, and then I caught it and added it. Period now is technically, we're not going to worry too much about the period because we're going to use the asymptotes anyway. But period technically now is pi over b instead of 2 pi over b. Here's what I want you to add. So I have this on your sheet where it's bx plus c is between negative pi over 2 and pi over 2. That's for the tangent graph. That's where the asymptotes are normally located. And once we start doing shifts or stretches, we can figure out where they go. For cotangent, we just saw that it's from 0 to 0 and pi. Okay? You've got an asymptote at 0, you've got an asymptote at pi, 2 pi, 3 pi, so on and so forth. So make sure you add the cotangent one. It's not on the sheet. And like we said before, x-intercepts are always just halfway between the asymptotes. Okay? So if you can find those asymptotes using this concept, then you can find the point in between, and everything else is a sketch from there, okay? Based on whether it's tangent or cotangent. Just to give you a heads up so you're understanding, so this is not just some random formula that you're using, by the way. So remember, B and C deal with the period and the phase shift. So we could take things and we could shift it left or right. We could stretch it out, shrink it down. It's going to move those asymptotes around is the idea. So on a tangent graph, the parent function, we have asymptotes at negative pi over 2 and pi over 2. On a tangent or cotangent graph, we have asymptotes between 0 and pi. If we end up solving for x, it'll tell you where you've got 2 consecutive asymptotes. That's what this is doing, which is why I don't really have to worry about the period too much, because this will take care of it. Okay? Let me show you what I'm talking about on the next one. Let's go into the actual example here. Let's graph this tangent function. I think you're going to find out, by the way, that tangent and cotangent aren't that bad in terms of graphing, because there's not a lot that you have to do, and most of it's a sketch. I would say they're definitely easier than sine and cosine. Okay? All right, let's take a look. So in this case, we said step number 1, I need to find where are the asymptotes for this graph now. Now that I've changed some values in here, I've changed the b and the c value a little bit. Okay? So if we take a look, all right, so if we take a look, we're going to take what's in parentheses, the bx plus c. So in this case, the 2x minus pi over 2, and we're going to sandwich it in between what we talked about on the previous slide, because it's a tangent graph, the parent function, the asymptotes, are normally at negative pi over 2 and positive pi over 2. What we're going to do is we're going to solve for x, and that will tell you then where your new asymptotes are located, 2 consecutive asymptotes. So if I solve this inequality for x, I need to take that negative pi over 2 and add it to both places. Okay? I'm going to take this, add pi over 2, we'll add it to the right, and then I'm going to also add it over here to the left. So on the left-hand side, we get 0, less than or equal to 2x, less than or equal to, on the right-hand side, we end up with, what's pi over 2 plus pi over 2? Pi. Okay, you get 2 pi over 2, which simplifies to pi. And now if we finish this off and solve for x, we divide everything by 2, which means the asymptotes for this graph, 0 divided by 2, one of them is at 0, and the next one, if we go in the positive direction, is at pi over 2. This tells you where 2 consecutive asymptotes are located. And then from there, we can just kind of work our way out if we wanted to build from there. That's the key part, though. Find the asymptotes. So now let's sketch the graph. Let's see what we actually have going on here. Let's see. So we said we have a vertical asymptote at 0. I'm going to put one in there. We said the next asymptote, according to what we found, is at pi over 2. So let's put one here at pi over 2. If we kept this pattern going, where would the next vertical asymptote be then? Yep, we'd go another pi over 2. So here's the period right here. For this tangent graph, from 0 to pi over 2. So now we just copy it. Now we go with the same thing. Next asymptote would be at pi. If I went one more, where would the next one be? Not that I have to, but where would it be? 3 pi over 2. Here's 1/2 pi. Here's pi. Now we're at 1.5 pi, or 3 pi over 2. And if we really wanted to, I could go in the negative direction too. I'm not going to worry about it, but we could. All right, now we find the points in between. Now we find our x-intercepts. What's halfway between 0 and pi over 2? Pi over 4. Yep. What's halfway between pi over 2 and pi? What is it? 3 pi over 4. Yep. If you think about it now, if you start looking at this with common denominators, this is 1 pi over 4. There's 2 pi over 4. 3 pi over 4. Next asymptote's really 4 pi over 4. We're just going by fourths. So the next point would be at 5 pi over 4. If you got everything in the same denominator, you're just going by fourths. And now, last thing, we can just sketch in the graph. And because this is a tangent graph rather than a cotangent graph, that means we start down low and it ends up high. And in this case, I actually put together 3 periods rather than 2. Okay. What do you think? Not too bad, right? Hopefully. This is tangent and cotangent right here. This is your process. That's the important features of what you need to find. Where are the asymptotes and where are the x-intercepts? All right. So there's tangent and cotangent. Now let's get into the last two, cosecant and secant. And this is where we're going to go back to sine and cosine waves again like we did before break. So if you take a look at cosecant, remember, we're going to do a little bit of sine and a little bit of what we were just talking about. Cosecant is the reciprocal of sine, which means sine cannot equal 0. We're going to have vertical asymptotes wherever the sine is equal to 0. And we're going to work off of the graph of sine to get that. Okay, so we'll kind of put those two, the idea that we're going to have asymptotes with sine and the idea that we have the graph of sine. Let's start there. So I'm going to go back to, let's sketch the parent function graph of sine again. Okay, so, and then we'll create the cosecant graph off of it. So if you remember back, we have sine wave starts at the origin, okay, if we don't have any shifts or anything. Starts at the origin. Then, as you work your way through, at pi over 2, we are up here at our maximum of 1. Then we go another pi over 2 to pi, and we are down here at our minimum of -1. Then we go to 3 pi over 2, back to a midline point again. Oh, hang on. I messed that up, didn't I? How come you didn't yell at me? Whoops. Midline point, minimum. There we go. I missed the midline one. And then finally, back at 2 pi. We're back to a midline point. So here's our parent function graph of our sine wave again. Now that I have sine, now I can graph cosecant off of that. Okay? Two things we have to be aware of. Number one, we said sine cannot equal 0. Well, if you notice, the sine equals 0 right there, which means we have a vertical asymptote right here. Next time sine equals 0 is right here at pi. Therefore, here's another vertical asymptote right here. And then again at 2 pi. Here's another vertical asymptote. And again, any other place where the sine would equal 0, we have a vertical asymptote for cosecant. Okay? Because of the fact that we have sine in the denominator, cosecant being the reciprocal. Okay? So sine cannot equal 0. Here's where the rest of it comes now. Now we're going to sketch the graph off of this. So if we take a look, when we sketch our cosecant graph, the idea is this. We're just taking a whole bunch of reciprocals. So think about it this way. As this graph is increasing on sine, okay, let's say we're at 1/3. What's the reciprocal of 1/3? 3 over 1, right? Then let's say we go to 2/3. What's the reciprocal of 2/3? 3 over 2, okay? The idea is this. As these y values are increasing, the values on the cosecant are actually decreasing. Here's what that looks like as a graph. Looks something like that. These values are decreasing. If I took this point right here and I took the reciprocal of it, it would give me that point right there. That's what I meant about, like, if that's 1/3, then that's 3 over 1. If this point right here is 2/3, then this point up here is 3 over 2. Okay? So that's what's happening there. Same thing keeps going. Now as the graphs, or as the y values decrease on the cosecant, they're actually increasing. And that process then just keeps continuing where we work off of this. So if we take a look, the next part would look something like this. And we would just keep, almost looks like a parabola opening up, then a parabola opening down, parabola up, parabola down, parabola up. It's that repeated pattern when you look at a cosecant graph. Quick question that I have for you. The period is always how long it takes for the pattern to repeat itself. How long, and I've only graphed part of this, I haven't graphed a lot, but how long will it take for this, or what's the period, I guess I should say, of cosecant? Is it pi or is it 2 pi? Let me ask you that. What is it, Kaylin? 2 pi. Why is it 2 pi and not pi? Yeah. This parabola that's opening down is not a repeat of that. You've got up, then down. Then the next one would be opening up, then down. That's the pattern of one opening up and one opening down is one period. Then you'd have another open up, open down. So the period, which shouldn't be too much of a surprise, by the way, is 2 pi. Just like sine, the period was 2 pi. When you take the reciprocal, it's still 2 pi. That does not change. The main thing I want you to understand, when you're graphing a cosecant graph, you're going to really just graph a sine wave and then work off of it. Okay? You're just graphing a sine wave and then working off of that. All right, one last one, and that one's secant. And again, it's kind of the same idea. Remember that secant is the reciprocal of cosine. Therefore, anywhere where the cosine would equal 0, you have vertical asymptotes. We're going to go through the exact same process when you graph a secant graph. Only difference, we're going to work off of the cosine graph instead. Okay, so let's put that together. We'll speed this one up here a little bit. Let's put our cosecant or our cosine graph together. So normally, cosine starts at a maximum, okay, maximum of 1. Then at pi over 2, we're at a midline point. We go another pi over 2 to pi. Now we're at our minimum value. And we're at 3 pi over 2, back to a midline. And finally, 2 pi. We start the process over. We're back at a maximum again. There's your parent function. There's your cosine graph. Now we graph the secant off of that. We said the cosine cannot equal 0. We can't have that, because otherwise you'd have 0 in the denominator. Where's the cosine equal 0? Based on our graph. Pi over 2 and 3 pi over 2. Here's the zeros, which mean that's where you're going to have vertical asymptotes. Those are the values that you cannot have. You can't have the cosine equal 0. And then it's the exact same thing as what we were doing before. We're going to work off of our cosine graph to get our secant graph. Let me switch colors. Therefore, there's part of it. Then we move to the next set of asymptotes, just like we did before. And we'll just keeps end up being a reflection up and down off of the cosine graph. Granted, I only graphed half of the parabola. This would continue if I went into the negative part. You would have the other half of the parabola. Same thing, if I went past 2 pi, you'd have the other half. Okay? I just stopped at 2 pi because that's where our cosine wave normally stops. And once again, just like always, the period again is 2 pi. It takes 2 pi for the entire pattern to repeat. Okay. All right. There's the main ideas. Let's take a look at then some examples. Let's work our way through some examples where we shift some things. Okay. All right. And I think hopefully we'll have time for 2. All right, first part. When you see this, if we're trying to graph the secant, what you really need to see this as is y equals the cosine of x minus pi. We're going to graph the cosine wave first, and then work off of it. That's really the most important part is get your cosine wave. So let's go back to what we did before break. Let's go back to cosine again. What's the amplitude for that cosine? 1. Remember, that's the number in front of the cosine. So amplitude is 1. Okay. What's the value of d? What's my vertical shift? 0. Midline, remember, add or subtract at the end or at the beginning. In this case, we are not shifting anything vertically. Okay. Then we take a look. What's the value of b? 1. Remember, that's the number in front of the x, or sometimes you have theta, okay? And it's that number in front. And remember that b helps you find the period. Okay? Remember that the period is 2 pi divided by b. So in this case, the period of this cosine wave is 2 pi. Okay. And finally, the last part, that's our phase shift, our horizontal shift. Okay, that's where we shift our starting point. So in this case, what's the value of c? Negative pi, which means our phase shift is the opposite of c divided by b. So the opposite of that divided by 1 gives you a phase shift of pi. All right. Now we're going to graph the cosine wave, because once we've got the cosine, like I said, then it's very quick to put in the secant. So let's go through and graph this based on what we have. So first off, remember we always have to get our starting point first. That's what our phase shift does. It shifts the starting point left or right. So we're shifting it to the right, pi. And since what I'm graphing right now is a cosine wave, what am I shifting? Midline or maximum? Heard both. Midline or max? Look at your cosine wave. Where does it start? Starts at a maximum. Okay? Use your, if you need, again, if you still need those parent functions, use them. It's perfectly fine. Starts at a maximum, so that's what you're shifting. And we said our amplitude was 1. So here is your starting point for your cosine wave. Okay. To that then, we're going to add the period. Okay. So 2 pi later, we'll have the next maximum. We'll have gone through a complete wave. So if you work your way through it, let's say now we're over here. Let's call that 3 pi. And that's where the next maximum will occur. Okay? So take your starting point, add the period to get the next maximum. And now we break it down in between like we did before break. Okay? Halfway between pi over 2 and 3 pi over 2 is 2 pi. Or excuse me, pi and 3 pi is 2 pi. What's happening at 2 pi? Midline or minimum? Yeah, again, if you need it, use your parent function. Halfway between two maximums on a cosine is always a minimum. So we're down here at -1. And then halfway between those will give you the midline points. Halfway between pi and 2 pi? 3 pi over 2. And halfway between 2 pi and 3 pi? 5 pi over 2. So this is at least one wave, okay? And again, similar to what I had you do before break, I'm going to have you do 2 periods, okay? Normally on the assignments, on your test that you're going to end up having, I'll have you graph 2 periods. But now, you just did the hard part. Now we just fill in all the rest of it. Where do I have vertical asymptotes? Nate, where is it? I think I read your lips correctly.
3 pi over 2.
Yeah. And
5 pi over 2.
wherever the cosine would equal 0, which in this case is 3 pi over 2 and 5 pi over 2, you're going to have vertical asymptotes. Okay. So here's one vertical asymptote. Here's the next. Like I said, if we continued this and did a second full period of the cosine wave, we would have more asymptotes in that case. And the rest of it is a sketch off of the graph what you have. There's part of that. Here's the next part. And there's your secant. There's at least one period of a secant graph. There. Nope, not here. Coming back a little bit, hopefully. Sine waves, cosine waves. I know it's been a week and a half. I know this was your favorite stuff before we left. Made everybody super happy. I remember. All right, let's do one more. Last example. Let's do a cosecant one. And this we'll wrap up on this one. Again, when you see a cosecant graph, hi.
You can't see it because it says Cosecant.
What's
Mr.
up?
Gertzenberger back when?
Next week, I think.
Not this week at all?
I don't think so. I think it's next week.
For finals?
Yeah.
Oh, look at I got a lot of my papers in here. Look at that.
They are loving it.
Oh.
They love graphing sine and cosine waves and everything else. Nothing but fun. So when we're looking at a cosecant graph, remember, what we're really graphing is a sine wave, and then working off of it. So this is really 4 times the sine of x plus pi over 4. We're going to graph that sine wave, and then graph the cosecant off of the sine wave. Okay? Let's start again. A value, what's the amplitude? That's the 4. Okay? So there's one of the things we'll have on the graph. What's the D value? What's the vertical shift? Zero. There's nothing added or subtracted to the beginning or the end. So there is no vertical shift. B value. Once again, just like the last example, number in front of the x, that's 1, which means the period of this sine wave is still 2 pi. That has not changed, okay, because B is 1. And the last part, C, is the positive pi over 4, which means the phase shift then, we use C to get the phase shift, the horizontal shift, is the opposite of C divided by B. So in this case, negative pi over 4. Phase shift and period are your two main features that you need in order to get your sine or cosine wave. All right, let's put it together. So first off, phase shift is negative pi over 4, so we're going from the y-axis to the left now. So let's put in here a negative pi over 4. And what's happening at negative pi over 4? Midline or maximum? This one's a midline because we're dealing with a sine wave. Okay? So here's your first midline point of your sine wave. And now from here, to get to the end of your sine wave, you add the period. I'm going to do it a little differently on this one because I think it's easier. Remember, if you take the period and you divide it by 4, every sine or cosine wave, there's 4 equal parts. Okay? So if I take that and divide it by 4, that'll kind of tell me what I need to go by. Which, if I divide that by 4, I'm not even going to reduce it. Why am I not going to reduce it? Because now we have a common denominator. So if I'm starting at negative pi over 4, the next important point here, the next key point, will be 2 pi over 4 later. So if I add 2 pi over 4 to that, we get pi over 4. Therefore, midline, the next one we go up to a maximum, which in this case, because of our amplitude, is at 4. Then we go another 2 pi over 4 to get to the next important point, which puts us at 3 pi over 4. There's our next midline. Then we go another 2 pi over 4, which puts us at 5 pi over 4. There's our, in this case, down at negative 4, there's our first minimum right there. And then a final another 2 pi over 4 brings us to 7 pi over 4. That brings us right back to our midline. There's the sine wave. Again, that's the harder part, is trying to graph the sine or cosine wave. Now everything else works off of that. Where are the asymptotes? Where do we sketch in the graph? Once again, remember, asymptotes occur wherever the sine equals 0. So I know I've got one here. I know I've got another one over here. And I know I've got another one over here. And if we kept going, this again is only one period of the sine wave. You would have gone a second period as well and added some more asymptotes. And the rest of it, you sketch the graph off of that. In between these two asymptotes, There's kind of the parabola that you'll see there, in between the next two asymptotes. There's the parabola that you would see there. And again, it would just keep going. Okay. How we doing, okay? I know it's a lot, especially for the first day back. It's not like this is easy stuff jumping right back in. But what I have for you today, I've got a worksheet for you. Here's the good news on the worksheet. The x-axis is already actually set up for you. You don't have to worry about trying to set up the y and the x-axis. It's already set up for you. You just have to figure out where are the asymptotes, so it'll help you a little bit. I specifically chose this worksheet as day one, making it hopefully a little bit easier for you. Tomorrow, like I said, there's nothing new. It's just going to be any questions you have from this worksheet. And then I've got another assignment just to give you a chance to practice it and get better at it and ask questions. Okay? But otherwise, tomorrow will be kind of a question and work day. All right, let me get you the assignment.